Welcome back. Today's goal of this lecture. Today I will see what is the arguments principle. This is today's goal of this lecture. For this, at first recall the meromorphic function. We all of us know the meromorphic function means a function is said to be meromorphic in a domain D if it is analytic throughout the domain, whole D, except the poles. Only singularity here, poles. And these poles are isolated singularity. Then this function is called meromorphic function. Without this singularity, the function is analytic. And for argument principle, recalls at first what is the zeros and poles. For this, if f has 0 at the point z equal to z0 of order m, then fz equal to z minus z0 to the power m phi z, where phi z is analytic and phi is analytic at the point z0 and phi z0 is not equal to 0. And if f has a pole at the point z equal to z0 with multiplicity m, then fz equal to psi z divided by z minus z0 to the power m, where psi z, this psi z is analytic obviously at the point z0 and psi z0 is not equal to 0, and the function has a pole at the point z equal to z0. Because in argument principle, zeros and poles would be used. The principles, this argument principle depends on zeros of a function and poles of a function and meromorphic function. So just recall these three parts. Actually, argument principle very important for any competitive exam, CSR, NET, GATE. So just recall meromorphic function, zeros of a function, poles of a function. Okay. Now let's see what is the statement of argument principle. Principle is for a function fz and simple closed contour C, what is the value of the integration 1 over 2 pi I integration f prime z divided by fz dz. What is the value of this type of integral? This is actually the argument principle. See what is the statement of argument principle. Let fz be analytic inside and on a simple closed contour C, except for a finite number of poles inside C, because only argument principle also only satisfy for meromorphic function. Meromorphic function means there exists only singularity is poles, and suppose that fz is not equal to 0, then integration 1 over 2 pi I f prime z over fz, this value is equal to n minus p, where this n is the number of zeros of the function and p is the number of poles of this function. This is the statement of argument principle, and this proof is very easy type proof. Just see any standard book, you will see this proof. If you don't understand this proof, please do comments in comments box. I will prove it. Today I will only use this argument principle. I will see many example depends of argument principle. This is today's goal of this lecture. At first, just see the statement of argument principle concentration, because this statement actually very important. Okay. At first see one example. Let's see one example on this argument principle. Find the integration mod z equal to pi cot pi z Which of the following are true? We all of us know cot pi z means mod z equal to pi cos pi z divided by sin pi z. Here I will use the argument principle. Consider fz equal to sin pi z. Then f prime z equal to pi times cos pi z. Okay, and integration cos pi z divided by sin pi z mod z equal to pi, this value would be, since f prime z means here pi cos z, so just divide 1 over pi times pi cos pi z over sin pi z, and here fz equal to sin pi z, and the contour is z equal to pi. That means here the value of the pi is 3.14, and we all of us know zeros of sin pi z are at the point n, and since here the contour 3.14, that means in this contour the zeros are 0 at the point 1, at the point 2, at the point -1, at the point -2, and at the point 3 and -3. That means number of 0 are -3, -2, -1, 0, 1, 2, 3. Here 3, 3, here 3, here 3, 3 plus 3, 6 plus 1, 7. Number of 0 of sin pi z in this contour is 7. And sin pi z, this function has no poles. Therefore, cot pi z in the contour mod z equal to pi, this value would be pi over pi cos pi z over sin pi z, and this is equal to, by the argument principle, because argument principles means 1 over 2 pi I f prime z over fz dz, this value is equal to n minus p, where n is the number of 0 and p is the number of p, and this value is the equal to, that means this value equal to pi times 2 pi I times number of 0 is 7. That means this value is equal to, sorry, why pi? Here would be 1 over pi. This value is equal to 14i. That means correct option is 14i. I hope my all viewers have understood this type of question. Okay. By argument principle, you can evaluate this type of integration very easily. Okay. OA. Next example, fz equal to z cube e to the power z square, for z belongs to C, and gamma be the circle, gamma be the those curve where z equal to e to the power I theta, where theta lies between 0 to 4 pi. Then integration between gamma f prime z over fz, what is the value? We all of us know this is actually argument principle, and 1 over 2 pi I integration f prime z divide fz, this value is equal to n minus p, where n is the number of zeros and p is the number of poles. Here given fz equal to z cube e to the power z square and gamma be the z equal to e to the power I theta, that means unit circle of radius 1, but here z equal to e to the power I theta, but theta lies between 0 to 4 pi. That means here the rotation, this rotation is 0 to 2 pi, then again rotation 0 to 2 pi. That means here 2 rotation. Okay, well, that means 1 over 2 pi I f prime z divide fz, this value is equal to, since fz equal to z cube e to the power z square, so number of zeros is z cube e to the power z square equal to 0. Number of 0 is 0, 0, 0 with multiplicity 3. And there are no poles, that means this value is equal to 3. But here student will be wrong. They will be thought this value is 3. But notice here not one rotation, here 2 rotation. So this would be multiplied with 2. So the value is 6. I hope my all viewers have understood this question easily. Okay, well, next, few minutes ago I had seen integration cos z dz. Here now I will see integration tan z dz. Here the contour modulus of z minus pi by 2 equal to 1. That means here tan z means sin z over cos z. So fz equal to cos z. That means f prime z equal to minus sin z dz. So here would be dz also. Here would be dz. I have done one wrong. Okay, here would be dz. Here f prime z equal to minus sin z. That means minus f prime z over fz equal to, since the fz is cos z, so fz has zeros, cos z equal to 0, that means this value is equal to z equal to 2n plus 1 into pi by 2. Okay, that means this function has 0 at the point 2n plus 1 pi by 2 where n belongs to integer. And here the contour z minus pi by 2 equal to 1. That means this unit circle about the point pi by 2. Unit circle about the point pi by 2. That means here only 1 zeros. This is pi by 2 inside the circle when n equal to 0. This pi by 2 only zeros inside the circle. I hope my all viewers have understood. That means this value is minus 2 pi I, number of zeros is 1 and number of poles is 0, that means into 1, that means this value is minus 2 pi I. Okay, I hope my all viewers have understood this easily. Okay. Next question, not tangent. Here tan hyperbolic z around the circle mod z equal to 3. Here fz equal to cos hyperbolic z, and we all of us know cos iz equal to cos hyperbolic z and sin iz equal to I sin hyperbolic z. Then zeros of cos hyperbolic z is cos iz equal to 0. This is equal to 2n plus 1 into pi by 2. This is equal to iz. Iz equal to 2n plus 1 into pi by 2. That means z equal to minus I times 2n plus 1 into pi by 2. Okay. This is the zeros. Zeros of cos hyperbolic z. And f prime z equal to sin hyperbolic z. That means, and here the circle mod z equal to 3, that means the center at 0, radius 3. This is 30, this is minus 30, and only plus minus pi by 2 be the inside in this circle, because pi by 2 means 3.14 over 2, this value is plus minus, this value would be less than 1, this is would be less inside this circle, but if you consider n equal to 1, then this value would be plus minus 3 pi by 2. Pi by 2 means 3. Pi means 3.14 over 2. This value would be greater than 3. That means only this value be the inside on the circle. So, this value would be 2 pi I, because 2 pi I into 2, because number of 0 is plus minus 2, that means number of 0 is 2. So this value is 4 pi I. I hope my all viewers have understood this type of question easily. Okay, well. Next question, this is also here use the argument principle. Notice integration e to the power z over e to the power z minus 1 dz. Here the circle mod z equal to 3 pi. Here fz equal to e to the power z minus 1. That means number of zeros are e to the power z minus 1 equal to 0. That means e to the power z equal to e to the power 2 pi ni. That imply z equal to 2 pi ni. Okay. That means this value integration e to the power z over e to the power z minus 1, this value is here the circle mod z equal to 2 pi. That means only when n equal to 0, 0 and 2 pi, these 2 zeros are inside in the circle. So this value is 2 pi I into number of zeros is 2, that means this value is 4 pi I. I hope my all viewers have understood this type of question easily. Okay, well. Next question, integration mod z equal to pi, here tan pi z. That means the zeros are here tan pi z means sin pi z over cos pi z. Here is fz equal to similarly cos pi z, and pi z equal to plus minus 2n plus 1 into pi by 2. Here would be pi would be cancelled. That means z equal to plus minus 2n plus 1 into pi by 2. Here the circle is mod z equal to pi. That means the circle with center 0 and radius pi. That means 3.14. When n equal to 0, then this value is plus minus half. When n equal to 1, then this value is plus minus 3 over 2. When n equal to 2, then this value is plus minus 5 over 2. That means this 6 point lies inside the circle. So this value would be 2 pi I into 6. That means 12 pi I. I hope my all viewers have understood this question easily. Okay. Next example, which had come GATE 2022 exam. The question is similarly use the argument principle. Here z to the power 100 over z to the power 101 plus 1 dz, where C is the circle of radius 2, centered at origin, taken anti-clockwise direction of centered origin, radius 2. That means this is the circle, radius 2 circle. Consider fz equal to z to the power 101 plus 1, f prime z equal to 101 times z to the power 100. That means this would be 101 integration z100 over z101 plus 1 dz, and this value equal to 101 times 2 pi I times number of zeros inside C. Here zeros of fz is means z to the power 101 plus 1 equal to zeros. That imply z to the power 101 equal to minus 1. That means z equal to minus 1 over 101, and this value is minus 1. And if we apply mod z equal to 1, that means this function fz has 101 number of zeros on the circle mod z equal to on the circle mod z equal to 1. That means in this region there are 101 number of zeros. So the number of zeros is 101. Cancel 100. This value is 2 pi I. I hope my all viewers have understood this question easily. Okay. Well, I will stop here. In my next video, I will discuss again more question and more corollary about argument principle. Okay. But at first, I will highly recommend you please see today's video with pay attention. Okay. See you soon. Stay safe and stay positive here, and don't forget to subscribe my channel for more videos. Thank you so much.